I think you all have seen this, and this, of course, is the pathway leading to caspase activation, and it involves a number of different steps. There are the BH3 only triggers that activate BAX and BAC, which then activate cytochrome C caspase and cellular apoptosis. And this is regulated through the so-called guardians made up of the BCL2 family members. And so this really, I think, has been a really, I've always kind of considered this in many ways kind of like the holy grail of targeted therapy, because Carlo was the first one to show this as an oncogene in lymphoid tumors, and it clearly is a hallmark of follicular. And so when I had the opportunity to start working with Abbott on this numbers of years ago, I really felt that it was a very exciting target. And so Abbott actually, who has been leading this area, worked on trying to develop these so-called BH3 mimetics that would be able to bind up these guardians and therefore release BAX and BAC to activate caspases. And so a number of different strategies over the years were used. One of the first ones was trying to actually inhibit mRNAs, and that strategy really didn't work. And so really the focus has been then on trying to go after the protein, and this is where the BH3 mimetics come in. So Abbott did a lot of work. I think it took them over 10 years, and they came up with a compound that was the first compound they came up with, and what is used in the lab is so-called ABT 7337, and then there was a very similar oral compound, which is the one that actually went clinically, called ABT 263. And if we actually look at the ability of the BH3 BAD to bind BCL2, BCLXL, and BCLW, you can see here that it's got very low nanomolar KIs. And if you then look at the ABT 263 that ultimately went into patients, and of course 737 is almost virtually identical, you can see that it was very, very similar to the other BH3 proteins. And so that's what really led to this drug actually coming forward. And so we worked with let me just say here that the major focus of this drug was to inhibit BCL2, but it also was also very potent against BCLXL, and it became very clear early on that this is a very important regulator of platelet senescence. And then BCLW is important for the integrity of spermatogenesis. So this is actually the phase 1/2 clinical trial design. We did a phase 1 dose escalation, and once we identified the MTD, we did expansion cohorts, and we actually looked at two different schedules. We did one which was a 21-day cycle for 14 days on, 7 days off, and then a second schedule which was basically 21 days on, so this was actually nonstop therapy. And so what we found from a pharmacokinetic point of view was that this is an oral drug. The Cmax was achieved in about 8 hours. The half-life was around 14 to 20 hours, so leading to a drug that could be given as a once a day, and that the inter-subject of AUC was around 40%, which is pretty typical for many, many drugs, particularly oral. And actually, again, it was shown very early on. In fact, the very first patient that I ever gave ABT 2632 is that we actually saw that the platelets fell. And that you can see that this ultimately, this is looking at the platelet nadir, and this is looking as a function of dose, 110, 100, 1,000, and you can see that there's a very nice correlation between dose and the platelet nadir. And what we would typically see, and these are showing individual cases, the platelet counts at the dose of 440, is we would see a very rapid fall, and then we would eventually see the platelets on continuous therapy begin to climb up again. And the reason for this is that younger platelets would be, we believe the reason for this is that younger platelets would be released from the marrow. They had higher levels of BCL-XL, so that they were more resistant to the effects of this drug, and that's why you would see the platelet counts climb up. However, most patients ended up with a level on chronic therapy that was somewhat below, albeit safely, above any kind of safe levels, but below what their starting platelet count was. So really, it turned out that the major dose-limiting toxicities at the end of the day with this drug were mostly related to grade 4 thrombocytopenia, although we were beginning to see effects on people who had been on this drug for a very long time on the neutrophil as well. And this is something which we tended to see in patients that had been on it for a very long time. And so it was very gratifying to see that when we put SLL cases on this actually became early on a very famous slide. This is one of my cases. It's a patient who had prior therapy with FR and had massive disease, and it just shrank down, you can see, after four cycles. So we really were seeing a very dramatic effect on nodal disease with this agent. If you look at the waterfall plot as a function of the actual dose, and keep in mind this was over a variety of dose levels, you can see that almost all cases had some degree of nodal shrinkage. So again, like we've seen for other targeted agents, most people do seem to have some kind of benefit from this. And so if we actually then look at the phase 2 overall response rate, looking at all 26 cases at the time that we had this data, the overall response rate was 24. And if we actually looked at it within the CLL, SLL group, small numbers here, we have certainly have more now. It was actually higher. And there didn't seem to be a very large difference in terms of the response rate between arm A and B. Then that was the 14-day on, 7 days off versus continuous therapy. So after we did this, it really became very clear that we were going to be limited in terms of how high dosing we were going to be able to get because of its effects on the platelets, and this, of course, was being driven by BCL-XL. And so Abbott took this very seriously and looked at actually the reversed engineered this drug so that it no longer bound to the P4 hydrophobic binding pocket, which was what was responsible for its BCL-XL binding. And so in this reversed engineered drug, we no longer saw the same degree of binding. And actually, when they then actually went and looked at that new drug, and that is ABT-199, which is the drug that they are currently looking at, and they looked at the EC50 of ABT-199 versus 263 across a large panel of cell lines, ABT in fact had a almost consistently lower EC50 than ABT-263. It also turned out that this is actually looking at the ABT-199 EC50 as a function of whether or not the BCL2 is high versus low. And one of the things that also came out of these clinical trials was that if you didn't have adequate levels of BCL2, which was its target, that the drug was not effective. And similarly, if you had very high levels of MCL1, which is not a target of this, that also predicted no response. And like was seen with 263, there was a nice correlation between higher levels of BCL2 and a lower EC50. So this is actually looking at the EC50 of ABT-199 versus 263, and you can see that 263 has a much lower EC50, consistent with the fact that it's able to bind to this hydrophobic pocket, and that the effects of 1999 on platelets at much higher AUCs was very, very low as compared to 263. And so this drug is the drug that AbbVie is taking forward, and this is actually John Seymour's presentation at ASCO last year, where they looked at ABT-199 in relapsed refractory CLL. And again, they were focusing on CLL because that was the group that we saw the greatest activity for with 263. So this is a group of 56 cases, 67 years median age, 4 prior lines of therapy, and a number of these appeared to be refractory to standard therapy. Fludarabine refractory 32%, and deletion of 17p in 38%. I have to tell you, I have no idea how they define this, so I'm always very suspicious when I see data like this. So what did they see overall? They saw overall cases actually a very nice CR rate of 84%, with almost 18% of them being in a CR or a near CR with this. They also showed that 30 of 30 patients that had high counts showed a greater than 50% drop. Now, when they looked specifically in the cases that they called 17p, whatever that was, you can see that they similarly had a very equivalent response rate. So like we've seen with ibrutinib and we've seen with idelalisib, this drug, because it does not work through a standard genotoxic pathway, it is not dependent on the p53 cascade for its activity. Similarly, if we looked at the fludarabine refractory group, response rate was 78%. Importantly, unlike 263, thrombocytopenia has not been an issue with this drug, which is the reason why this drug was taken forward. Kind of a double-edged sword, though, is that they have had some very serious episodes of tumor lysis syndrome, including some deaths. And at this point, it was 11% had tumor lysis syndrome, but I understand that these numbers have actually risen. And so what they are attempting to do is using a ramped scheduling where they start at a very low dose, and then they gradually increase the dose up within a individual patient, and they have very stringent criteria for observing and trying to ameliorate tumor lysis syndrome. And so what we can say, though, is that with ABT-199, that it appears to be an extremely promising drug, that it has very high activity in CLL. Again, I think the finding of tumor lysis syndrome is something that should not deter us from this drug going forward, but it may well be a drug that is better used in a consolidation phase. We don't see the kind of thrombocytopenia that we saw with 263, and so I think that they need to move forward with trying to find a safe phase 2 schedule for this, and then go into combination trials.